Okay, I guess we got about 15 minutes, so I'll kick off immediately. My name is Tom Virant. I am a head of data science at eBay for payments and risk. What that kind of means is we own all fraud detection at eBay. Just a quick overview of the team so you know where some of the commentary in this presentation kind of comes from. So currently have about 15 data scientists as well as software engineers on the team. Which means we're kind of full stack from building models to some data engineers, software engineers help push production applications and deploy our models as well. Of course, we're hiring, have about 5 open roles. And okay, let's just jump right into it. So today, what I really want to walk through is my journey. So I started eBay about 5 years ago when I came on board. I think we had like 1 or 2 batch models. This is when eBay and PayPal split. We had 1 or 2 batch models built in SAS and running off Teradata, right? Just generic stuff, couple models. Through the last 4.5, 5 years, we progressed and grew from obviously 1 data scientist to 15. We have probably 70 models deployed today across batch implementations all the way to near real time to fully synchronous ones running in 20 milliseconds type of applications. Today's discussion is more so a walkthrough of the stuff I've learned on that journey. You know, obviously that's a rocky road and we're still developing. We still don't have a perfect platform. Some of the stuff I showed today is still in the, hey, be nice to have, but I know we need it. Some of the stuff is fully matured, but I want to walk you guys through kind of what I've been doing and to get you thinking about this. If you're at the beginning of your career, if you're starting just to deploy a couple models, you know, what do I need to think about so that you do it correctly and you're not constantly rebuilding and stepping over yourself through the years? So obviously we're going to focus on the kind of end-to-end data science lifecycle here. You know, as it says, it doesn't fit every need. This is kind of a generic framework for what to think about. Everybody has unique use cases. Not going to go into the super technical details, but just kind of the gotchas and big broader topics as we have 15 minutes. You know what, this kind of started because, you know, if you think about a simple use case that I have, it's, okay, Tom, we need to build models for seller registration at eBay globally. And as you can see, the numbers add up. Every country, we have consumers, we have businesses, we have, you know, we have different data sources in each country. If you think about different credit bureaus, all of a sudden these things add up to where, hey, just a simple registration, just one piece of the entire end-to-end ecosystem for me. Hey, we could end up with like 40 models. Like, how do you manage all these data vendors, all these data sources, 40 models in production? And the scary thing is, like, this model suite, if something went wrong on my side, we'd actually shut down seller registration. So, you know, it's kind of important to me to monitor that. You know, what I said at the beginning is start thinking about this, because why is getting this right important? And it really is about you know, ongoing maintenance. You get it right up front, you're not going to be scrambling. And, you know, as people will find out, as you start deploying 1, 2, 3, 4 models, all of a sudden your data scientists are spending all their time monitoring, fixing things, as opposed to building great solutions. So that's why this is a little extra important. So what are the key requirements? Just, you know, a simple walkthrough what happens when you score a model. You have a request. Maybe that request is in batch. Maybe that's from a certain application in the production environment. Like I mentioned, a user registering, you know, sends a request to your system to get a score back and fits into a larger strategy. At that point, you call data systems. You create your features from those raw data points if they're not already stored in the system. You score, potentially you overlay a strategy. And then, of course, you respond back, but also log everything as well. Today, we're going to run through 4 key areas. Number 1, data management. As you can manage, that's actually the bane of my existence right now. Data management is difficult. Tech functionality, a little more straightforward, but a few things to think about there. Of course, governance. As you get up to over a few models, governance is key. Especially when you have attrition, which is high in data science areas, right? And people coming and going, you need to know what's there. And of course, monitoring, which is another hot topic recently for me. Even if it's not just for yourself, the entire organization wants to know how things are going and wants to know when things are breaking. As I mentioned earlier, something breaking could be catastrophic depending on your application. Okay, so data management. And I see I've already used quite a bit of time, so I'll speed up a little bit. Number one, centralized data repository. This is very important, as I mentioned, with all the different data sources, bringing those all to a centralized location for links into your application. For us in production, it's like, okay, it's great. You have one API. There's a backend system that manages all of this. It's simplified versus making tons of external calls, which gets complicated across your model suites. As well as when you have a centralized repository, it allows you, because that centralized repository may feed multiple models. So if something breaks, you know exactly how it impacts your suites of models. Thirdly, it makes things reusable. Today we have a centralized repository both in batch as well as in production, such that, hey, we might run a group of 3,000 variables in Hadoop. We store it. We use that across 30, 40 models running in batch each day, as opposed to having independent data stores or independent data fetches. It's much easier to manage. Get into catalogs and documentation. Pretty self-explanatory here. Catalog, you can use GitHub, some of this. Otherwise, graphical user interfaces are nice, which we have as well. It lets you know what is the definition behind each variable, as well as tracking changes of that. Very important to the business. Third is a big topic on data quality. I'll talk about that later. Training to production. One big issue we run into is I build something out of a data warehouse. I put it into a production environment. How do you match the data, and how do you keep that ongoing? This is always a struggle for us. I have not streamlined this process, but for us, we on training and production, we definitely match data warehouse data to cumbersome process to production data. We store those definitions in GitHub on each side, and we reuse those across our model suites, so you know exactly what you're building is what you're putting into production. Obviously, once you get into after you have a first model deployed, which moves into the model pipelining aspect, you do save all that logs, and rebuilding models on production data is obviously the way to go if you're not adding new features. And that is the key about that modeling pipeline, because that really puts it all together, and you can now auto retrain, and you're not worrying about the whole data quality piece. But up front, the data quality is that is a cumbersome process. Oh, sorry guys, I'm looking at two screens and I forgot to proceed. It's a little different on online. Sorry about that. I was reading on one side. So there we go. You have catalogs, documentation, data quality, and kind of your ML pipelining. Okay, let's jump into technical functionality. This time I will not forget to proceed. So feature creation. One thing we come into is interesting. And I think it's one of the questions as well, is how do we build everything in Python. We deploy everything in batch in Python, but also in Java. We're not using Scala right now, but Java for our low latency applications, as well as now we're in the midst of building out a enterprise deployment solution that includes deployment in Python as well. So this is where we actually keep our feature repositories, and we match that Python code to the Java code, similar to what I mentioned about your data repository, so that we can match the two, and we reuse those. So that's another process to match between the two, but that we have to make in those cases. But you need to obviously keep that code documented. Model ingestion, a lot of different options out there. We use PMML as well as pickle files. Sometimes PMML causes us trouble, as everybody. Of course, go into deep learning, there's other objects as well. So not much to say there, except obviously you need to have options on that side in case you run into issues. Champion Challenger model selection. So this is key. Obviously, you need to have champion challenger capability, not just because you're iterating and testing, but also how do you upload a new model then swap over? You better upload into a challenger mode, test, then swap. Also the functionality of model selection, like I mentioned in our first use case, for onboarding, we might get a single service call, but we may have 40 different models. Ability to select which one you want to run for certain kind of containerized applications like that, when you have a suite of models for a specific use case, is important to us. Okay, governance. This is where we get into some of actually that data catalog as well. As you have many people, as you have a larger team like me, and you also have engineering teams that are helping you out, it's important to set standards on who can edit code, who can check in code, who has access to that, to reduce risk of any changes in the platform. Version control, this moves into kind of in my next one, a model lifecycle management, where we actually host and have a model repository. Model repository has every past, every current model object, along with all the metadata in it, being what version are you on, what are all the parameters used to fit that model, where are all the inputs and outputs, etc., all in some metadata. It's great to manage, and you can also push and pull. You can push models from that repository into your applications. Yeah, on that aspect, that's also key. Moving into the last piece of the puzzle, which is monitoring. Not as sexy as building a model, but this is super important. It's interesting, population stability, which on a score aspect, for me, it's like, okay, things are always kind of stable, not a big deal. This became important for me over the weekend as we had a data platform kind of issues, and I only noticed it because all of our models at the same time had a big drift in score. So it actually became very important for me over the weekend. But also in population stability, you also get into kind of the data quality aspects. You better be monitoring all of your data points at all time to know if there is not just on our engineering side, they're always monitoring, data on or off. Oh, it's on, there's data, okay? For me, it's important to know the quality of that data. And that's actually the most difficult thing to monitor is quality. We're actually working through that today. I don't have a perfect solution for it. I know there's some vendors out there I'm talking to in other areas in data quality. Of course, model performance, this we kind of run on a daily basis. Better know how your model's performing. Obviously we have our logs from our ML pipelines, and then we add back into model performance, different maturity levels on that performance, but that's something we definitely monitor on a daily, weekly basis for our entire model suite. And also transparency there is key, so we put that up into publicly available kind of dashboards. Lastly is alerting. Some of our applications, like I said, we check for stolen credit cards on our site. So if something goes offline, either A, you fail open, A, any credit card you use goes through, B, you fail close, we shut down eBay. So sometimes alerting is very important on the population stability as well as how the model's performing. Obviously for us, it links into a 24/7 monitoring from our kind of site operations center and other areas, but alerts are also key. Alerts are kind of difficult to knowing at what levels to alert. Okay, closing off and kind of wrapping up this entire presentation is, data is obviously quite complex. The whole data management piece from taking data warehouse data to putting that into production is very cumbersome and difficult. Moving into the quality aspect of data, like I mentioned, we're still working on that. How do you do that in real time? How do you know when, like I said, like over the weekend, some of the data systems, hey, they're producing data, but something went off on them because of some issues. Maybe it's not caught in other systems. How do you manage against that? Moving into just the AI engine, I didn't mention here earlier, but obviously there's a lot of publicly available, like what I've kind of gone through today. Some of this is available. So a lot of companies are building enterprise solutions for this. We're working on it for ourselves, but Michelangelo with Uber, they've put a big presentation on that. You can look up. Obviously you have AWS and SageMaker and all these other platforms that kind of have these end-to-end solutions somewhat that you can use. We're building ours in this house. Depends on what works for your application. You might want to look into some of those as well. And lastly, very important, you better know how your items are working, right? Or when you feedback to all your business partners, you better be on top of that on a daily, weekly basis. So that is all I got, ending right about on time, which leaves us 5 minutes for Q&A. So let me pull up that. Hopefully I am sharing. Let me refresh. Okay, let's go down from top to bottom on the votes there. So multiple languages, I kind of covered off on some of that. All of our builds are in Python today. All of our batch deployments, we just take our build data and use that for our batch deployments. With such, we do keep a data repository, such we reuse all those features as well as data points across the models. Now, when we move into Python versus Java, that's where, again, we have to do, most things aren't that complex that we do in terms of feature creation. But the ones that are, obviously, we do keep a GitHub on, here's the Java feature repository and matched up to these on the Python side. And we do keep that in GitHub, and that's how we kind of manage it today, of transferring to a Java model. In terms of the model objects, we still keep the same objects. We deploy it through Java. We use PMML in our Java application today. Make that easy. And scalability, so for me, that's easy. eBay has massive internal systems to scale for us. I mean, today our production system, we run at about 500 transactions a second. We have 46 computers across 3 data centers. For me, we push an application. The corporation kind of handles some of that, pushing out to the 3 data centers, scaling to multiple systems. So that's easy. So I can't really comment too much on that, since it's all the systems allow that to be easily done here at eBay, at least. Okay. Recommended resources, courses, experts, blogs. That's a good one. So I think in the terms of deployment systems, I think that there is a lot of good documentation around, go look up Uber Michelangelo. They have a blog on that and talking through what they did. B, you have Amazon, I think the SageMaker's name. They have somewhat okay documentation. It's a little not as good as Uber, if I remember correctly. And lastly, Azure has, if I remember, I looked at this like 6 months ago, but Azure platform has some really good documentation on what their capabilities are. So I think those are some things to learn a little bit about this end-to-end deployment lifecycle on those blogs. Okay, what solution to use for a centralized data repository? So 2 things. We have so it's not just my team. We have lots of engineers that support us as we're building out centralized capabilities across eBay. But today we do all that in HDFS Hadoop. And there's some other teams that have built some wrappers on top of that to allow us to more readily manage our data repository. And they've built a solution such that, we have code that runs each day. Obviously, it's all Spark SQL stored into Hadoop. And the other solutions allow us to easily push that into Couchbase to be available in production, or we run it we loop into that repository for our models. And of course, there's other wrappers other teams have made that make that a little easier for us. Okay, number 4, data distribution shift because of COVID. So we've experienced that, obviously, specifically, and we monitor our kind of APAC sellers. For us, I mean, we don't really handle the distribution shift. We actually adjusted our strategy on our model slightly there, because obviously some shipping problems caused increase in what we perceive to be risk based on the shipping and handling times when they weren't really. So we actually just, on the back end, we made some simple strategy adjustments on some of those, as opposed to refitting. The more severe would be refit of the whole model, which then you'd have to refit again here in a month, or B, maybe you artificially just kind of suppress some of those in the data field, I suppose. But for us, we just we changed strategies on the back end, and that's an important thing here as part of the system. I didn't mention really is capabilities to readily adjust your strategy, not just a score cutoff, but strategy or a strategy tree based on, hey, I'm going to shift the score cutoff for different regions of the world if you have a global model or other things. And that feeds back into monitoring as well to make sure you have a problem to do such a thing. Okay, 1 more minute. I'll go back and answer some of these online later today as well. How do you consider product grow and changes? So for us, I think product growth, I kind of think about this as changes into our eBay ecosystem, which we actually operate more as a service to those, where if things are going to change, which might push, for me, that means things might push into changes in our data. And sometimes we get kind of heads up on that. And certain of those variables we might have to remove from a model and refit in terms of if there's a major shift in some of those variables. Okay, I think that is all on my time today. I know I spoke really fast since I had more content than time, but reach out to me on the app and I'll go through and answer some more of these questions through the day. Everybody have a great afternoon.